Well, hello everyone. My name is Tony. I'm here with Christian, and some of you have already seen our live stream from last week. Today, Christian and I, mainly Christian though, I have to say, are going to code an interactive riddle. But before we continue, Christian, let me quickly check if you're live on Twitter. Okay.
We are.
We are live and ready to roll. Amazing. Well, once again, welcome to all of you. Thanks for tuning in our weekly Thursdays live stream session. Today, as I said, we're coding an interactive riddle. Last week, we had a parametric prediction market example with a sports bet on football. I don't remember which team it was anymore, but we're definitely gonna release the live stream on YouTube as well, so everyone can have a look. Today, we continue with this riddle, and some of you in the community may already know this riddle because it's been part of what we call the Galactic Event Series on Friday, and this time it's just a very special Galactic event. So yeah, I reached out to Christian and asked him if we can make this happen on GenLayer in the studio actually, and I think it truly shows what we have in our name, the first intelligent blockchain, unlocking AI-powered dApps, because this is truly another example of real-time data fetching. So yeah, welcome, Christian. Before you start, I'm going to give the floor to you for the coding part because I would just embarrass myself. Before we start, I would just like to mention, as with every space live stream that we're hosting, you're going to get a POAP at the end of the live stream, which you can mint, that is going to be used for future rewards. So you need the POAP home app. And at the end of the live stream, I'm going to share a secret password, which you can simply enter in the POAP home app. It's very simple, 2 steps, and then you can mint your special POAP. Okay, without further ado, I've talked too much already, Christian. I'm going to give the stage to you. It's super interesting for me also to see the riddle live as an intelligent contract. So you shared the screen with me. Once again, thanks for joining us, and the floor is yours.
Thank you, Tony. Thank you, and everyone. Hello. Yeah, I mean, after the last Thursday event that we were showing the prediction market, we enjoyed that much that we just want to continue, right? And don't forget that this is the first approach to work on the intelligent contract, right? As a set of all the developer tools, in the coming future, you will be able to develop your intelligent contracts in your IDE, like using VS Code, Cursor, whatever you're using, right? And actually deploying from them as you do with other projects, such as you want to deploy a smart contract on Ethereum. And also, probably in the coming future as well, we will not see some decentralized application frontend interacting with the studio, so you can actually see the dApp working with all its components and UI, not just the set of methods in the studio you can interact with. Okay, so let's get started then. So as always, we need to start with the version setting of our intelligent contract, right? Setting the GenVM version. Don't worry if we see any errors right now, because there are going to be some syntax errors. The next thing, we are going to import the libraries that we are going to be using whenever we are implementing our intelligent contract, right? So in this case, I'm not sure. Yeah, we use the same data classes from Python last time that allow us to set more and better typing and object-oriented style to our data structure and our contract state, right? So, right, we have we're going to import field and data class. Okay, then we cannot forget from GenLayer import everything, right? Because we need the full SDK here. Okay, so how it's gonna be this riddle? We're going to have different stages. In this case, we're going to start with 3. If we have more time, we can add more in this session. But just to start and to not making that very, very long, we're going to set some stages, right? So the goal is that the player starts in stage 1, and if they answer correct, they move to the next stage and so on, okay? So I'm going to let you read a little bit. Yes,
here.
Tony.
Let me just quickly explain for those who didn't know the galactic event. That's how it's called. So this is a slight adaptation. It's about a riddle. So you imagine you are in the role of, a spaceship commander, or like a president of a foreign galaxy, Earth, planet, whatever, and you have to solve a riddle that has 3 to 5, 6 parts, and you have to answer by multiple choice answers a question that is in the riddle, right? And the first one, for instance, you can see, you can already see it here. I think you wanted to show the whole trial anyway. But just for everyone to understand, so Christian is dividing it into 3 steps, kind of the coding logic behind it, right? And for those of you who didn't know the riddle, that's the setup of it's a classic riddle with a story, a question, and then you have 4 answer solutions. Yeah, sorry, Christian, go on.
Exactly. Every stage is consists on some description, right? One question and some answers. In this case, for the sake of the example, we have the answer right here. Of course, this in the blockchain wouldn't be like a good idea, right? Anyone could inspect our intelligent contract and know the answer already, mostly because also in GenLayer, you code your intelligent contracts on Python. So even by looking on the Explorer at the deployment transaction of this contract, you will be able to see the full code, not the compiled bytecode as you see on EVM chains. So of course, this is for the sake of the example, but in the second stage, we are going to make a more dynamic question, and we are not going to give like an answer right here. We are going to set in this stage that the answer is on this URL, and we are going to fetch the content of that URL straight on our intelligent contract, and we are going to pass a prompt to an LLM to analyze the user answer based on this web content, okay? And on every stage, we also have like some comment in case the user answered it correct, and we move the user to the next stage, okay? So I'm gonna leave this at the bottom of the file so it doesn't get like a too crowded there when we are adding the code, and we can work a little bit cleaner, right? So let's define our data structures, the state that we are going to store for our contract, right? What we want the user to actually record their answers and their progress. So in this case, we need to use the data class decorator to add a class that we're going to call stage, right? This is like a single stage for our contract. So in this case, we're going to have step, which we need to define as a U256. We are very intentional about not setting integers, like a wide integers. We're trying to be specific about it, right? The content of the question, right? Let's define exactly this structure here, so we can load all these stages on the state of our contract, and we can work with it, right? So in this case, this is a string, the answer, which is also a string, but in this case, it's optional, right? So we are going to use the fill method from the data classes to say that the default is an empty string, right? Then we have the answer URL, which is the same as an empty string, and the answer comment exactly as they are. All right. We are going to also, for convenience, to define here a class method to allow us to load in a more easy way all the stages into our contract state. Is going to be the from dictionary, right? And we're going to return an instance of this data class. Spell this. All right. Now we're going to need another thing to store all the players' progress, right? So in this case, let's define what is going to be the player stage, right? So we're going to have the step of the user, what they're currently on, and the content of the current stage, so we can fetch it more easily without having to go through the entire stages to see what's the content for that. Okay. All right. So this would be our data structure, and now we create our intelligent contract. Let's call it Galactic Trial in this case, and let's define the storage, right? That we're going to have here. So we have the trial stages. In this case, it's going to be the array of stage, right? And we are going to have all the player status. Status is it's just about the name, which is going to be a tree map, right? As we did with the prediction market, if you remember, where we are going to map addresses of every user to player stage, right? So in this case, for every user, for every address, for every account, we are going to have its stage, right? It's a status of where they are. Okay, so in this case right now, let's define our constructor, right? Oh, sorry. And let's populate that trial stages array, okay? We could always reference to the static array. We could pass it through the constructor parameters. I mean, we can do whatever, right? There are many alternatives. So trial stages is going to be an array where we are going to call this method that we just created from our data class, right? Let's spread the whole stage dict, right? For every stage dict in the array of stages, okay? That should be most of it. Let's also start with a method that allows to read what's the current status of a given player, so we can start deploying it earlier. And it's always like a good advice not to wait until we have the whole code developed, because debugging our contract them is going to be harder to spot all the bugs and all the syntax error that we might have added. So it is important to start deploying as soon as possible and start interacting with it, just for reducing the load of debugging the whole thing, right? So in this case, it's going to be a read method, right? Public.view, and we're going to call it get player status, okay? So in this case, we're going to add to receive the player address, because this will allow us to know the status of every player, right? As you may know, yeah, usually on the smart contracts, you also on read methods, you don't care too much about the sender, because it could be anyone, right? It's just reading from the intelligent contract. In this case, I'm going to parse first the player address, converting, right, casting that to an address, right? And now I can look for in the player status. Let's see if this is already in the player status, and if it's not, right, our parsed player address is not in self.player status. I will call him player statuses all the time. So in this case, we cannot return anything, right? We just can, for the sake of the example, return something like game not started, right? That would be enough for now. But in case that we do have it, right, we just want to return that, right? This the current status of the player status at our parsed player address. Okay, let's go to the run and debug section in our studio to start inspecting at the code, fixing any syntax error. Maybe this was the first time in my life where there was no error in the contract. We can just go straight and deploy it. We're very lucky. Okay, but let's pay attention because maybe we have some runtime errors. So we need to pay attention. The execution was a success. So that's great. We have here our method, and we can copy our address from here, right, and use it to get our status. In this case, we should expect to receive a game not started response, right? Okay, we can see that there was some execution error right here. Let's see how it went. Okay, we, as I said, there were no syntax error at the beginning, but we made some runtime error, right? So in this case, I probably parsed and parse. Let's ensure that this is all right, right? So now we can deploy again. Let's copy our address and get ready to test it and see if we get that game not start.
It would have been too nice on the first try.
Yeah, game not started. All right, let's add now a method, right? It's trying to make it a little bit like a increase in complexity, right? To start the game, right? I'm trying also to imagine what would happen if we have a front-end decentralized application. How would we interact with it? So let's say that we connect our wallet. So maybe that at that point we can call this init method to just not start the game, but just to give the user the initial information about how's the game, what it consists on, and all of that. Okay, so let's go and code our init game method. In this case, it's going to initialize the game for the player. So we need to declare as a write method, right? So it's going to be init game, and in this case, we don't need to receive anything, nothing to return. Okay, so I'm going to define some variable right here that is going to be the game intro text that I had as the stages from before, right? So in this case, it's going to be some explanation about the how to test your knowledge and to set the mood for the user. Okay, so in this case, we need to start, right, the player status to add a new player stage to our set of player statuses. So in this case, we're going to start with using very intensely in this example. If you recall from the last time that we were doing this live stream about getting the user address from the transaction, right? Which is a very common practice also in other blockchain projects, because if the transaction is signed with your private key, you can ensure that that address is yours, right? That transaction is from you, at least from your private key. So it is a very good way of authenticating users, right, so to speak. So in this case, we're going to use the user, the sender, right? The message in the transaction, the address of the user that is sending the transaction. So in this case, we want to add a new entry to our player status, right? Which is going to be at the user was sending a transaction. In this case, with GenLayer, we get it as gl.message.sender account. As I said the last time, this is going to change soon by sender address, which is more accurate, okay? And in this case, it's going to be player stage, right? A new instance of this data class with the initial step, which is going to be 0, and the content, which is going to be this game intro, right? All right, I think I'm not missing anything. So we can just go and deploy this again and test it if we can init our game. Okay, I'm going to copy again the address just to be prepared for the get player status. Let's see if everything went well. Yes, it seems. Let's call the init game. Okay, see how it executes the whole transaction. And whenever it's ready, we can go and fetch the player status. Okay, so in this case, it's not again the game is not started. It's right now. We have the intro here, which we can show on our front end, right? We can say, okay, you're in the step 0. This is the intro. Okay, let's now start the game, right? Let's try to go on these ones a little bit faster, just for being time conscious. All right, public.write, and we are going to in this case is a start game. We could maybe do both at the same time, but it's trying to get complexity increasing every time, right? So the start step is going to be the 0. This will allow also to allow the player to restart the game if they want to start all over again. So the stage that we need to start the player with, right? To locate the player is going to be the first one. So it's going to be trial stages at the start step, which is the 0, right? And in this case, let's also update the player status at that player, right? I'm going to copy this just to be a little bit faster on the example and to be sure that we finish on time, right? So player stage, and we have, right, what do we have? The step, right, which is the first one, stage.step, and we have the content of that stage. Okay. All right, so let me save this. Let's deploy it. Now we can init the game, start it, and see what's the first question. Okay. Oh, maybe we just messed up a bit. Start the step. Trial stages. Start step. Why don't we look at the error here? Okay. Let's see, maybe we can go to the execution, which is usually easier just to get the errors from, right? In this case, we can see where we couldn't get the schema for method, start game. Oh, we messed it here. Okay, now we can. Right, once it is accepted, we get our methods, we can init the game, and we can actually send both transactions right now because they are going to be processed in a queue, right? That's exactly how GenLayer works. We have a queue per intelligent contract, so every transaction needs the previous one to be processed until it gets actually the process. Okay, so they get processed in queue. Okay, so we have here our first question, that where is this called, right? What is your answer? So let's add our first method to solve the first step, right? So in this case, again, let's call it the solve step 1. Okay, and let's receive the answer from the user, right? Let's make it simple. So in this case, let's skip the validations for now so we can go a little bit faster. So let's see what's the answer of the user. So if the answer is of the user, we know that it's B, right? Because it's right here. We could also use an LLM to send the question, the correct answer, and whatever the user answers, and get the LLM decide if that's actually the user is referring to option B. But for the sake of the example, let's do it a little bit faster right now. So if the answer, let's ensure at least that we consider uppercase and lowercase. If it's B, right? Well, in this case, it was correct. So let's move the player to the next stage, right?
And Christian, a stage, just for understanding, right? The player, like if we on a casual blockchain setting, you would send the first transaction, and it has to go through. It has to be correct. That would be the stage x+1, right?
Yes.
And only if you have this stage, kind of, if this stage is represented on the blockchain, you can send transaction 2. If you don't have the stage, if the stage is not there that is required for stage 2, would you be able to send the transaction?
Yeah, exactly. That's what we are adding here, right? Let's validate if the user on its current status, if they are in the first step of all the stages, right? In the first one. If it's not, we don't even consider the answer. We just return an error and we don't process. So that means that the user only can execute the step that is right for them at any given moment. So in this case,
like a condition, yeah. If you don't have the correct answer to stage 1, you can't even process to stage 2. It's like
exactly.
Yeah.
Exactly. So in this case, if the answer is correct, very strictly, right, the player moves to the next one, and what we are doing is to getting this answer comment about, oh, you're right, this text that we can see here, and we add also the next stage content, so they know how to solve the next one. Okay, makes sense. Let's add right now the first to solve the second step, right? Okay, it's going to be solve step 2, self and the answer, right? As a string, we don't turn here. So in this case, it's going to be a little bit different, right? Because we are asking if there were a new LLM release this week, and we're going to say to the LLM to fetch the answer from here. So we need to do kind of different things here. So let's see how we can figure it out, right? So in this case, we can just get the same validation as before, but with the current step, right? If the user is not in the second step, we don't want to process this. So, and now we need to declare as a local variables all the things that we're going to use in our non-deterministic code, right? Because otherwise it's going to fail. So the player answer is answer. The stage content is the stage trial stages at the first position, right? Because it's the stage 2 dot content, and the answer URL, which is same stages. Oh, sorry. At 1 dot answer URL. Right now, we are going to code our non-deterministic part of the method, right? Let's call it check answer, right? Which is going to return a Boolean, which is if it's correct or not, or actually it is a JSON, right? So let's ask a dictionary. So right now, let's fetch first the web data from the answer URL, right? So web data is going to be, right? Let's use our SDK gen layer to get web page content, right? And what we're gonna fetch, the answer URL, right? And with the mode text, right? After this, let me paste my prompt because it's a little bit too long and we are going to spend maybe too much time. So in this case, what we're gonna do, we're going to say to the LLM that they are the master of a game. Here is the content about the question, so you can get the context. Here is the web data, right? Here is the answer of the player, and here is the expected answer that we want from them. Okay, so in this case, after we have this prompt, we can query this, execute the prompt, and get the answer.
And that's the part where, so the first part, we had the answer kind of in the riddle already, right?
Yeah.
If you remember, I asked you this question, like, how can we make the answer not publicly appear? But that's not possible because it's a blockchain. So if you have the answer in your riddle already, it's there, right? But this part really shows that the same as in the prediction market last week, the LLM, the intelligent contract fetches data from the internet and returns if your answer is correct.
Exactly. So there is this whole prompt in our non-deterministic code. We execute this prompt, right, as part of our non-deterministic code, and we return a JSON of that, with hopefully is this object with the answer if it's correct, and the comment of the LLM that wants to make about the user answer. After that, we use the equivalence principle method. In this case, is strictly equivalent. That means that validators and leader are going to execute the whole thing, right, with the check answer. And now we can know if result is correct, right? So in this case, what do we gonna do? We're going to move the player to the next stage, right, and to add the content as we were doing before, right? So we put the player on the third step, in the third stage, and we set the new status for this player, right, as the answer from the step and the content for the next one. Otherwise, if it's not correct, right, we can say invalid answer, for example, right? Now we can deploy it, we can test it.
And we will definitely, because I'm just aware of time as we have to leave. Let's give our listeners, our viewers actually the answer. And we are gonna have this full riddle with 6 answers implemented in the future. So watch out, especially if you're in our community. Join the Discord, join the Telegram in our X bio. Christian is going to show you the answer now. Again, please mint the POAP using the secret passphrase B minus my minus Genfran on the POAP home app. And Christian is solving step 2 right now.
Yeah, I just sent all the transactions just to get ready as soon as possible. And then, yeah, hopefully we can see all were executed. And right now we have our second one that is going to be executed. Right now it's proposing by the leader. It's executing the whole code. Hopefully, oh, we made a mistake. So probably there is a syntax error right here someplace. Maybe we can. What if we post the full contract in Discord after it, just for timing?
Yeah, I think that's a very good idea as well. Yeah. Okay. I think this is a very good example. It gives you an overview of what you can do with GenLayer. What was especially, I asked you, hey, Christian, can we make this happen? And you immediately said yes. For me, it's really cool to see how you can work in stages, which are states on the blockchain. As we said before, if you fulfill stage 1, you can go to stage 2. And it really shows the data fetching capability of GenLayer and the processing actually of the natural language as well. Okay, Christian, we're going to post everything on Discord. Actually, we're going to have an event around this. So watch out, mint your POAP with the secret passphrase. Is there anything else you want to say, Christian?
No, let's post the full code in Discord and let everyone try one itself in studio.genleader.com.
Thank you, team. Thanks everyone for tuning in, and have a nice day. Thank you, Christian.
Bye bye.
Bye bye.